Hi everyone. Let's talk about the notation of definite integrals. First, let's review what definite integrals really are. Out of these 6 options, which one correctly defines the definite integral of the function f of x between a and b? If you would like to try this exercise on your own, stop the video now. You can also download these notes using the link in the video description. I will solve this exercise by using the process of elimination and the meaning of the definite integral. The definite integral gives us the net area between the graph of the function f of x and the x-axis. To compute that area, we use approximating rectangles. Each approximating rectangle has a certain width. That width is given by delta x, which suggests that option E is not applicable here. Option E says that the width of each approximating rectangle is b minus a, which is the length of the entire interval, which is incorrect. The width of each approximating rectangle is less than the length of the entire interval. To compute the area, we are supposed to use more and more approximating rectangles. Said differently, we are supposed to take the limit of those approximations. This suggests that option A and option C are not applicable. Because we are looking for more and more approximating rectangles, we are taking the limit as n goes to infinity and not as n goes to 0, which means that option B is also incorrect. To determine the height of each approximating rectangle, we plug in a sample point to the function from each subinterval. Because sample points are denoted by xi star, option D is the correct one, option F is incorrect, option D is the correct one. This option uses sample points instead of using integers as inputs. Before I move on, I wanted to briefly mention that the sum in the definition of the definite integral has its own name. We call it a Riemann sum. It was named after the first mathematician, Riemann, who defined definite integrals as the limit of those sums. Now we are ready to discuss the notation of definite integrals. Numbers a and b have their own name. They are called limits of integration. The number at the bottom, in our case number a, is called the lower limit of integration, and the number at the top, in our case b, is called the upper limit of integration. The function inside of the integral, in our case f of x, is called the integrand. The symbol at the end of the definite integral, in our case dx, is called a differential. The variable we are using here, in our case x, is called the variable of integration. There is one more thing I want to mention here. The notation for the definite integral reminds me of the definition of the definite integral. F of x reminds me of the height of each approximating rectangle. Dx reminds me of a tiny width of each approximating rectangle. F of x dx reminds me then of the area of one approximating rectangle. The integral sign, which looks like an S, reminds me to take the sum of all of these approximating rectangles between a and b. Then I simply need to take the limit of the resulting approximations as I use more and more rectangles. To see if we understand the notation of definite integrals, let's complete a problem. A student wants to find the area of the region shown below. The student writes the following integral. What is wrong with the student's answer? What is missing? Rewrite the integral correctly. If you would like to try this problem on your own, stop the video now. I believe that the student made a couple of mistakes. First, the student used an indefinite integral. However, to compute the area of a region under the graph of a function, you must use a definite integral. To fix it, I will use a definite integral with the lower limit of integration 1 and the upper limit of integration 3, because the area is between x equal to 1 and x equal to 3. I will use the same integrand x squared. One more thing that is missing is the differential. Because the function is written in terms of x, the differential is dx. If the function was written in terms of t, the differential would be dt. Every time you write an indefinite or definite integral, that integral must end with a differential, dx, dt, or d of the variable of integration.